Assalamualaikum warahmatullahi wabarakatuh to all of my respected students. Inshallah, for this lecture, we will see the topic of chapter 6, which is the properties of mixture. So for this topic, I divided the lecture to two parts, which part 1 and part 2, where in this topic, we will cover the thermodynamic description of mixture. This is part 1, where it will contain the measurement of concentration, partial properties, spontaneous mixing, ideal solution, and ideal dilute solution. Where in part 2, we will cover qualitative properties and the phase diagram of a mixture. In part 1, if you remember what is physical chemistry is always we talk about how to describe everything or the phenomena in a mathematical way. So we present it in numbers. So that's why we will involve with a lot of questions. For example, we will talk about Gibbs energy, for example, where energy is one kind of measurement that is take place to measure the energy or the spontaneity of a reaction, for example. So when we talk about energy itself, it is an abstract. It doesn't have value. We just can say that either this is a lot of energy or it involved with low energy. However, it is not sufficient. That's why we need to quantize it. We need to make it in a number form, so we can see it clearly the relation between the energy and how much energy that we need. So that's why we will talk about, in the first part is about how we want to quantify, or how we want to measure the mixture in the number form. So in this chapter, we will see how can we measure the phenomena. So inshallah, in this topic, we will go through a homogeneous mixture or solution. So when we talk about homogeneous mixture, we doesn't talk about the ion. What's ion? Ion is something that have a positive and negative charge. So we didn't talk or we don't discuss about ion at all in this chapter. So when we talk about mixture, we talk about a solution. When we talk about solution, it is a mixture of a solute and also solvent. When we mix it together, so we will have a solution. For example, in this diagram, we have a solute. We have salt as our solute and water as our solvent. So we mix it together. So we will have a salt solution. So in here, we know that salt have their own properties, their own physical properties, their own chemical properties. And same goes to water. Water is a type of solvent. It have their own properties. It have their own physical properties. However, when we mix it together, we add salt to it, we will have a salt solution. So now the salt solution have slightly a different property compared to salt, also compared to water as a solvent. So we will see how this thing, or how the salt and solvent will change slightly the properties. Okay, we will see in this topic. So for the first part, we will, I hope at the end of my lecture, you know how to measure the concentration of a solution, And so we know about the partial molar properties of a solution. What is spontaneous mixing? What is ideal solution? And derivation from a formula. So we will see, we will derive a formula from our Gibbs energy, our Clemens Gibbs energy derivation. So we will derive from there how to get another formula, and then we try to sketch a graph from our formula that we derived before. And also we need to know how to extract necessary information from the formula. So we know what is the formula that we derive, what is the formula, how to use it, what the function that we can obtain from it, and a lot more. So the first one is the measurement of relation. So as I said before, in physical chemistry or in chemistry, we didn't talk about this. The equation is thick. The equation is too dilute. No, we don't talk like that. We need to measure it. So how to measure it? We have a molarity, mass percent, molarity, mole fraction, and everything have their own formula. For example, molarity. What is molarity? Molarity is a mole per volume. Yeah. So to find more, we need to know how. We need to have a mass of an element, and also the molar mass of an element. So here is basic knowledge of chemistry. So I didn't want to talk much about it. You can refer it back to your previous knowledge, because we already learned about this in our secondary school. So same goes to mass percent, molality, and also mole fraction. Please have a look back at your matrix or time heading notes. It's very beneficial notes if you have. So again, what is solution? Solution is the mixture of solute and solvent. So we need to measure it precisely to have a good concentration. And next, the second part is a partial molar property of mixture. So we will talk about liquid and gas here. So for partial molar property, we can divide the two parts, which are partial molar property, partial molar volume, sorry, also partial molar Gibbs energy. Where in our partial molar Gibbs energy, we will see about the chemical potential and also standard chemical potential. So what is partial molar volume? So of course, when we talk about volume, we talk about a liquid and also gas. So for example, if you have a mixture of, if you have a liquid A and liquid B, it has their own volume. However, when we mix it together, the volume will be slightly differ. So when we talk about partial molar volume, this is about a concentration of substance, specific substance. We name it as J here, to the total volume of a mixture. For example, if we have a mixture of water and ethanol, you can say that is imagine that is water and this one is ethanol. So partial molar volume of ethanol, if we mix it together, will vary as the composition mixture change. For example, environment change from pure ethanol to pure water, given the formula of partial molar volume is V, the total volume equal to mole of volume A plus mole of volume B. And A and B is in a fraction. So here we can say, if we have this kind of graph, we can say that this is a graph for mixture of ethanol and water. When one mole of water is added to large volume of water, if we have water, we add another water, and the condition is at 25 degrees centigrade, we will say that the volume will increase by 18 centimeter cube. Because why? because the volume of 1 mole of water is 80 centimeter cube. The molar volume of pure water. However, if we have ethanol, and we add 1 mole of water in the ethanol, the increase of volume, only 14 centimeter cube. Why? Because the reason why is because the volume occupied by a given number of water molecules depends upon the aridity of the surrounding molecule. The value of 14 centimeter cube is said to be the partial molar volume of water in ethanol. So that's what I said, that a partial properties. For example, for this case, if we have water and we add 1 mole of water, the volume will increase 80 centimeter cube, because the volume of water for 1 mole of water is 80 centimeter cube. However, when we add the same amount of water in ethanol, right, the increase in volume is only 14 centimeter cube. Yeah. So we will see later in this topic why because of that. So clearly, if we going back to, if we still remember, molecule. If we have a molecule, we have a homogeneous molecule, same molecule in the container. So we will have we have a uniform distance between molecule and molecule, because we only have molecule of water and molecule of water. For example, however, if we have ethanol, so we add water. So now the interaction between molecules is different, because we have interaction between ethanol and water, and also water and water molecules. So that's why the interaction between the molecule will give a different properties. So for example, if we have this kind of question, what is the total volume of a mixture of 50 grams of ethanol and 50 grams of water at 35 degrees centigrade? For example, what is the total volume? So again, how we use the formula? So we need to have the formula, total volume of mixture. Here is our formula. And then so what we need to do is we need to find the mole of ethanol and also mole of water. So to find the mole of ethanol, we have a mass divided by molar mass. So we will have 1.09 mole for ethanol and also 2.77 mole for water. And then we need to find the mole fraction of each component in our system. So for ethanol, we have 1.09. So the total mole of the system is 1.09 plus 2.77. That's why we have 3.86. So the mole fraction of ethanol is 0.282. And then so mole fraction of water, same formula. So we just substitute the different value here. So we will have 0.718 as the mole fraction of water. So and if you want to find the volume, so we use the formula, and here so we will have this one. So the total volume of the mixture is 108.4 centimeter